Chapter 11 is all about simplifying radicals and solving radical equations. So if we are dealing with terms that have square roots in them, we first want to simplify the square roots and create some like terms in order to add or subtract them together. This is in class what we say, giving the numbers the same last name. So if you look at the first term, 3 root 2, we can't simplify that any further. But we know that the square root of 36 is 6, so we can rewrite that as 6. And then 6 root 8 can be further simplified. We know that 8 is the same thing as the square root of 4 times 2, and we can further break that up as the square root of 4 times the square root of 2, and we know that the square root of 4 is 2. So now we have 6 times 2 times root 2, and you can multiply the 6 and the 2 together and make it a 12. So now we see that we have a 3 root 2 and a 12 root 2, and we can add those together. 3 plus 12 is 15, and the root 2 just stays because it's the last name. And then we still have the minus 6, but that's not a like term, so our final answer is 15 root 2 minus 6. Simplifying the square root of 500, we want to think about a number that goes into 500 that we can take a square root of. So we know that 500 is the same as the square root of 100 times the square root of 5. And we know that the square root of 100 is 10, so our final answer is 10 root 5. For number 3, we have the square root of 27 times the square root of 10. And there's a few ways to do this problem. I think it's easiest to simplify first and then multiply. So we can break up the square root of 27 as the square root of 9 times the square root of 3. 10 can be broken up as the square root of 5 times the square root of 2. The only problem is we can't take the square root of 5 or the square root of 2. We can take the square root of 9, and the square root of 9 is 3. Since we can't take the square root of 3, 5, or 2, we can multiply all of those numbers together and leave them inside the radical. So 3 times 5 is 15, times 2 is 30. So our final answer is 3 square root 30. In problem 4, we need to graph y equals the square root of x minus 2. Since we have a minus 2 inside the radical, that's going to affect what we plug in for x. For example, I would not be allowed to plug in a 0 in this case, because then I would be taking the square root of negative 2, and we can't take the square root of any negative numbers. So 0 would not be a good number to plug in. The first number that we would actually be allowed to plug in is a 2, because then we'll be taking the square root of 0, and that's okay. So the square root of 2 minus 2 is the same as the square root of 0, which is 0. And then we want to think of another good number to plug in. If I plug in a 3, I will be taking the square root of 1, which is 1. And if I plug in a 4, that would not be the greatest number to plug in, because then we'll end up taking the square root of 2, which is a decimal. But if I plug in the number 6, I'll take the square root of 4, which is 2. And then let's plug in one more number so we have 4 points to work with. So we'll plug in an 11, because 11 minus 2 is 9, and the square root of 9 is 3. So now we're ready to graph. So we need to go all the way out to 11 on the x-axis. And only up to 3 on the y. So we have a point at 2, 0, 3, 1, 6, 2, and 11, 3. And remember, square root graphs start at a point and then they only have one arrow going off to the side. For number 5, we want to solve the square root of x plus 6 equals x. To undo a square root, we need to square. So we're going to square both sides. And a square undoes the square root, so now we just have x plus 6 equals x squared. Now, since we have an x squared, an x, and a 6, what we need to do is set it equal to 0 and then factor in order to find the answer. So I'm going to subtract x and subtract 6 to the other side. So now I have 0 equals x squared minus x minus 6. So when we factor, we need to think of two numbers that multiply to -6 but add to -1. So that would be -3 and +2. And then we need to take both factors, set them equal to 0, and solve. So we end up with x equals 3 and x equals -2. Now with these square root problems, you need to check for extraneous solutions. So if I take 3 and plug him back in, I'm going to have the square root of 3 plus 6 equals 3, and we get the square root of 9 equals 3, and that checks out. If I plug in a -2, I have the square root of -2 plus 6 equals -2. And we get the square root of 4 equals -2. Now this seems to be right, but if we're solving and we get a negative on the other side of the equation when we plug it back in, that's an extraneous solution. So x equals -2 is extraneous, and the only solution we want is x equals 3. That same topic brings us to number 6. We have the square root of x plus 2 equals -7. This actually cannot happen. We cannot have a negative on the other side of the equal sign. So as soon as you see a problem like this, the answer is no solution. For number 7, we want to find the midpoint between the points -2, -4, and 9, -4. So for this, we need to know the midpoint formula. The midpoint formula is x2 plus x1 divided by 2 and y2 plus y1 divided by 2. Basically, we just take our two x terms and we add them together, divide that answer by 2, and the two y terms, add them together and divide that by 2. So -2 plus 9 is 7 over 2, and -4 plus -4 is -8 over 2. So the final answer could either be 7/2, -4, or if you had it as a decimal, we would have 3.5, -4. Either of these answers could be a possibility because the test is multiple choice. Now we want to find the distance between 2 points. We want to find the distance between -1, -3, and 9, -13. So for this problem, we need to know the distance formula. The distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's plug everything in. So we're going to have the square root of x2, which is 9, minus x1, which is a negative 1, and then y2, negative 13, minus a negative 3. So these double negatives are going to turn into a positive. So we have 9 plus 1, which is 10 squared, plus negative 13 plus 3 is going to be a negative 10 squared. So we have the square root of 100 plus 100, which is the square root of 200. Now on the final, this final number can be simplified. So we have to go back to remembering how to simplify radicals. So for 200, we could break that up as the square root of 100 times the square root of 2. So our final answer would be 10 root 2. For this next problem, we definitely want to draw a picture to illustrate what's happening. So we have a cross-country team that leaves school and they run due west for 3 miles and then due north for 4 miles. And then they run directly back to school diagonally. And we want to know how far did the team run in total. So we already know that they ran 3 miles and 4 miles, so we just need to figure out how far they had to run back to school. So because we have formed a right triangle, we can use Pythagorean theorem. So we have 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared. So 25 equals c squared. So 5 equals c. So it was another 5 miles for them to run back to school. But the question is asking how far did they run in total. So 3 plus 4 plus 5 is 7 plus 5, which is 12 miles.